A missile is fired from a seaside cliff 300 feet above sea level at a 45-degree incline and a muzzle velocity of 75 feet per second. The height of the missile above the water is modeled by, so we have this equation, h of x is equal to negative 32x squared over 75 squared plus x plus 300, where x is the horizontal distance from the cliff face. So for part A, it says, at what horizontal distance from the cliff is the missile at its maximum height? All right, so we're trying to find the distance that the missile is from the cliff when it's at its maximum height. So what they're basically talking about is basically a maximum for the function. The function, you can tell by the x squared, is quadratic in nature. All right, so let's do a drawing to kind of illustrate what we're talking about here, just to get a visual aid. So basically we're saying, hey, there's some cliff face here, and from this cliff face, we're launching this missile. It goes up, hits a maximum, and begins to come back down, right? Forming a parabolic arc. That arc has a maximum, right? And we're trying to figure out, in other words, if you kind of drew a little dotted line here, how far out off the cliff face we are when that occurs, right? So how far in the horizontal direction. All right, well, we have a function that helps us do this. We just need to find the vertex of the function. And we have this nice little formula here which says, hey, the vertex is negative b over 2a for the x-coordinate of the vertex, and that's what we're looking for. Okay, so let's do that then. If the x-coordinate that we're looking for part A is equal to negative b over 2 times a, in our example, that will be negative 1, because the number in front of x is just 1. So we have negative 1 over 2 times that complicated looking fraction, minus 32 over 75 squared. All right, so just work that out using your calculator to perform the arithmetic. So you end up getting 87.89 roughly when you do that, and that of course will be in feet. Okay, so we have the answer to part A. Let's look at part B then. For part B, they say find the maximum height. Well, remember that this is the x-coordinate of the vertex. The max height is corresponding to the y-coordinate of the vertex, right? So how high is this point, basically, this is what we're asking. So we just plug that into the function. We basically need to do h of 87.89, and that'll give us the answer. Now, of course, plugging that in is going to be a little bit tedious because of the complicated function, but it's not impossible to do, right? Especially with a graphing calculator or just a regular calculator. Just plug that information in. Just be careful about when you're evaluating it, right? So 87.89 plus 300. So remember, you're looking for max height, and of course, h corresponds to height. So the function will give that to us if we just know the x-coordinate of where that max height occurs, which is what we found in part A. Okay, so we're just going to evaluate that function then at that point to see what we get. Okay, and so when I evaluate that, plugging all the arithmetic in, which I'll let you do on your own, you end up getting the height 343.95 feet. All right, and then finally, part C. It says, when the missile is 50 feet above sea level, how far is it from the cliff? Okay, so it's just a matter of evaluating the function at this point, right? So we're basically saying, okay, for part C, they're telling us that it's 50 feet above sea level. That's a height, right? So that means your h of x value is actually 50. And that will be equal to the function at negative 32x squared divided by 75 squared plus x plus 300. So we have to solve a quadratic equation, essentially. So we'll subtract 50 from both sides, minus 50 from both pieces there. That becomes 0, and that'll be equal to negative 32 over 75 squared, x squared plus x plus 250. And to do this, we need to use quadratic formula, right? You're not going to try to factor this probably, so we'll use quadratic formula, plug the values into that. Again, just because it's a little time consuming to do that, and you guys have done this before, I'm just going to go ahead and work it out for us and see what it would get. All right, so you end up with two solutions when you do the quadratic formula. You end up with x is equal to 315.2, or that x is equal to negative 139.4. All right, now we have to just interpret this, because can you have a negative when x represents the distance from the cliff face? Well, I think the answer to that is no, you cannot have a negative, right? There's no way to have a negative value in that case. So we can throw out that second solution and say that that's not valid, and we go ahead and accept that 315.12 is the answer. Now, why did we get a negative before? Well, let's try to look at the drawing one more time just to see where that's coming from, because of course you should never discard an answer without understanding why it's wrong. So here we have the cliff face, right? And this cliff face, I don't know if they told us how far it was. Yeah, they said it was 300 feet above sea level. So we know that the height of this is 300 feet, right? That's how tall it is. So think about the fact that we're launching this missile into the air, it hits a peak and comes back down and splashes into the ocean, right? They're asking basically how far is it from the cliff face at 50 feet? Well, in other words, that's way down here maybe, so maybe there's a little point where we're talking about 50 feet being right here, right before it splashes into the ocean down here below. Well, that missile is going to hit the peak, come down and splash into the ocean, and it can never be over here. Now the parabola, I've drawn it a little bit funny, but the general idea is the parabola itself is going like this if you actually plotted the actual function. Maybe it looks like that. And because of that, if it was allowed to hit kind of through the cliff face, we would actually be moving away from the initial target point. So in other words, we're saying be over here, and that's a distance of, it looks like a negative 139 is what we're saying. We'd have to be back here. But of course, it's not going there, right? Because it launches from here, it goes up in the air, and it comes back down. And so when it gets over here, this distance here, this piece right here, x, is 315.2 feet. So it makes sense to throw out the negative 139. And you can see why the function is telling us the answer is what it is. The problem is we could never actually be here because we're not launching it from the ground. We're launching it from the top of the cliff face, and it can never get down into this position. So it's basically starting from here in the middle, basically somewhere, comes down, goes into the water, splashes down. So a little bit complicated explanation there perhaps, but I think from the drawing you can kind of see what's going on. So it's not possible to have this negative 139.4, and so the only answer is at 315.2 feet. That's when you're about 50 feet above sea level.